Good afternoon, everyone. Am I audible to all?
Yes, sir. Good afternoon.
So let's start the session.
Yeah, so can I start?
No, sir. Don't listen.
Yeah, sure.
A very good morning, good afternoon to all of you. Today, I am introducing you all to Dr. Gokul S Krishnan, who is currently working as a research scientist at Robert Bosch Center for Data Science and Artificial Intelligence, IIT Madras. He has also worked as a postdoctoral fellow in the same center. He earned his PhD from NIT Karnataka, Suratpal, and also worked as a data scientist in Penzigo Technology Solution Private Limited, Bangalore. Today, Dr. Gokul S Krishnan will be delivering a lecture to us on the topic Natural Language Generation and Hallucination. Natural Language Generation, otherwise known as NLG, is a software process driven by artificial intelligence that produces natural, written, or spoken language from structured and unstructured data. It helps computer to feedback to user a human language that they can comprehend rather than it in the way of computer might. Dr. Gokul S. Krishnan will also be sharing with us his knowledge about hallucination. So please pay attention and hear out Dr. Gokul S. Krishnan in order to enhance your skills in natural language generation. And at the end, you may ask your doubts too. Hope you will gain some fruitful knowledge from this and will enjoy the session. Thank you. So you may start.
Yeah. Hi. Thank you for the kind introduction. I'm audible, right?
Yes.
Yeah, great. Okay. So hello everyone. I'm Gokul Krishnan. So I'm working as a research scientist at Robert Bosch Center for Data Science and AI. So let me just share my screen. Yeah. So I would like to just tell a few words about the center itself first before I go on to my presentation. So Robert Bosch Center for Data Science and Artificial Intelligence is at IIT Madras, and it's a very highly interdisciplinary center where we have different faculty from various departments. So around 35 faculty from 12 departments and 80 plus researchers. And we do have very significant output in terms of research publications. So we have numerous collaborations in the industry and things and even with the government organizations. We do work in various domains with various industrial organizations as well as government organizations. We do have some fellowships and internship programs and things like that. So post-baccalaureate fellowships is one of our most effective flagship programs where this is actually for graduates. So if you know people who have finished their bachelor's degree, that's what this is for. That's who this is for. And we have been seeing significant outcome from this program, right? And we do have special program for women as well. And this is just a stats of the number of applications we have received. As you can see, it's quite popular. And we do have few of our the selected people are from IITs, other CFTIs like NITs and IIITs, few overseas, and rest we have from private deemed universities and things like that. And we do have, out of the 23 people that have finished, we have data from around 21 people, and various people have been pursuing higher education. And we have few working in research centers as well. So out of this 17 who are pursuing higher education, most of them are abroad. And that too in very high ranked universities. We do have some internship opportunities as well. So the we do have some summer internships, and I urge all participants to keep a lookout for our summer internship call that should happen in the next couple of months. We do have postdoctoral applications as well for those who have finished their PhDs, which is how I came into the center. So that program is also available. So we are situated at IIT Madras, Bhupat and Jyoti School of Biosciences. So please do pay a visit if you are in campus or something like that. So just wanted to give a brief intro of where I'm from. And now I'll just go into my presentation. So I hope the slides are visible.
Yes, sir.
Yeah,
Visible, sir.
okay. Thank you. So, so what I'm going to talk about today is actually, I'm not just going into in-depth technicalities or mathematics of things. So I'm just going to scrape the surface of the, the various techniques that are there or various models that are there for generating text. And I'll be talking about some of the main challenges that you encounter, right? So hallucination is a serious challenge, and we'll be talking about that as well. So, if you want to reach out after this talk, please feel free to do so. And so what exactly is natural language generation? Actually, I think, you already heard a very good, much better definition of natural language generation. So it's nothing but a bunch of software systems generating text in natural language form, and it's considered as a subfield of computational linguistics and artificial intelligence. So currently it's very popular using deep learning, and it mainly with the advancement of transformers, we have been seeing a great deal of progress in this domain. So that's what we'll be talking about today. So I think everyone will be able to raise hands, right? So how many of you have been part of some, something like natural language processing or natural language understanding, natural language generation? How many of you have worked in such things? Can you raise your hands? Okay, I can see. Okay, 2 folks. Okay, so how many of you know natural language processing is? Yeah, okay, quite a bunch of hands. Yeah, cool. So anything that processes text is basically natural language processing. But to analyze the text and give some more understanding, some more decisions, like say sentiment analysis and things like that, it's called natural language understanding. So mostly text classification problems will appear under natural language understanding, and you have classical and traditional natural language generation as well, where you had to look at each token and you had to fill a template and things like that. But the combination of this, right? So natural language understanding by itself uses a lot of machine learning these days, and by combining these two, we have the current trend of natural language generation. So all the things in the middle of the Venn diagram, you can see chatbot, text summarization, question answering, so you can have question generation models, machine translation, and things like that. So you basically understand the context of the text and then decide what to generate, right? So that's the meaning of the combination. So this is another way of putting it, right? So you are surrounded by some data, you are fed some data. Considering all this data, I'm understanding what the context is, and according to the context, I'm generating some language in natural language form or human language form. So that's what natural language generation is all about. So for those folks who don't know exactly what natural language generation is, this is as simple as it can get. And there are a bunch of applications for this, right? So if you have seen summarization models and things like that, so if you go to a hospital, right? So nowadays you are having all this hospital information management systems where you have patient databases and things like that. So if you go to some bigger chain hospitals, you will notice that all your data is already there, and you don't even have to carry the prescription to the pharmacy because the pharmacy would have already received the order and things like that. So when you go to the doctor, actually the doctor is actually provided with a summary of your your data. So if you have had numerous visits, the doctor cannot spend time looking into it. So it has to be summarized and put in a very good form and provided to him. So for that, summarization is being used. You also generate reports and things like that. For that also, this can be quite useful. So how many of you know InShot's news application? I think it's quite popular. Yeah, I can see some hands. So InShots is actually using a great deal of natural language processing and summarization and things like that. So so please mind if I disable the video for a while. I'm having some network issues. Yeah. So other than that, we have real-time machine translation that is happening. So I'm sure a lot of you would have seen applications where it can translate from one language to another from audio itself, right? So that also requires a great bunch of natural language generation. Image captioning, so automatic generation of captions for a given image. So answering questions provided to the model and generate questions for a bunch of paragraphs given to it. And finally, conversational models. So I'm sure at least many of you would have interacted with either Siri or Google or something like Alexa and things like that. So when you talk to it, it is talking to you back. And when you are referring to some pronouns also, it's understanding what you are referring to. So, for example, you can ask follow-up questions also, right? So you are going to ask, say, how is the weather looking today? And it's going to answer you back. So you can actually follow up and continue the questionnaire, like continue about the rain and things like that. You can further ask questions and it will still continue the conversation. It will not tell as if it's a new answer to a new question. So conversational models are very interesting where you really need to have an entailment of what is happening. So if, for example, another example I can provide is, so when I'm asking about someone, say I'm asking, how is Gokul doing today? And the model is telling Gokul is doing fine. And the next time I ask, I'm just going to ask, will he be discharged from the hospital soon? So the model knows that he is being referred to Gokul and not someone else, right? So that feature is very important in conversational models. So in traditional natural language generation, we had a few steps that need to be followed. So first was the content analysis. Then you understand what kind of data it is, how you structure the document, what all sentences you should put together, what grammar you should follow. So should you put it in reported speech or active or passive voice and things like that. Finally, the language presentation in the natural language. So this was actually the steps followed in the traditional natural language generation pipeline. So the content analysis, you basically filter and clean out data. And then in the data understanding, you understand what kind of context you are in. So depending on that, you need to structure a document. So you may have already templates in place and you need to select which template you have to go for. And finally, bring out some sentences there, structure the grammar, and finally format the the template. So with information from maybe some conditional output or things like that, right? So this was actually how natural language generation was approached, but this has changed quite a bit right now because the way the deep learning models have taken over are quite different and the way they work is quite different. So this is just a neural model, how the neural models have evolved over time. You can see that the NLP is quite an old concept. So there are very good models in based on information retrieval and all in the 60s actually. So but they were like very minimal operations, and of course the capability of the computation we had was quite low that time, and accordingly the applications couldn't be scaled up, but still the techniques existed. And as you know, deep learning also, the neural networks concept also is quite old. You can see that the RNNs came out in the 80s and LS came in the 90s. So the only delay for them to be popular was what was stopping them was that the absence of good computation infrastructure and lack of data, which was solved post 2010. Right, we had great GPUs and huge improvement or increment in the data that was being generated by various users thanks to Web 2.0, that is the social network and things like that. We had huge data to work with. And finally, in 2014 to 2017 time, we had a sequence-to-sequence modeling, so which was based on RNNs and LSTMs. We were able to bring, build encoders and decoder-based architectures. So that was how machine translation actually became quite popular. And it was very interesting it was even more interesting to see how they worked pretty well with the presence of an attention layer, which came around in 2015. And finally, 2018, actually from 2017 itself, the transformers actually started, pushing the performance beyond limits and hitting it out of the park. So we had a very interesting paper called Attention is All You Need. So it's a very popular paper. So for folks who are yet to start on transformers and things like that, that's a very good place to start. So Attention is All You Need is the paper's title. And from there onwards, actually, if you see, NLP field has not looked back at all. They have been continuously booming in terms of, the progresses which they have made in the field is quite admirable. So that's where we are now. We are in the era of transformers. So for natural language generation, these three, which you see on the screen, were the primary models that were of interest. So RNNs and LSTMs, traditional RNNs and LSTMs were able to generate text to a certain extent for very small sentences and phrases. Seek-to-seek models could do it for a few paragraphs maybe, but we were able to see certain problems in the encoder-decoder architecture. So some of the problems was the long-term dependency of the models was not so proper. Once once the document was too long to process, the model was not performing well, which is why the attention layer was brought in, and it had quite a bit of improvement. However, it was pushed beyond limits by transformers. So how the transformers work is, quite not clear to a lot of people because it involves a lot of mathematics and, attention layer concepts. There are multiple kinds of attention layers. So I'm not going to delve into the underlying mathematics of it. Maybe that we could see for another talk or something like that. But what exactly happens inside the transformer is these two concepts, right? So one is self-supervised learning. So self-supervised learning. So how many of you have heard of self-supervised learning? Anyone? So I think everyone knows supervised learning, right? Yeah. Yeah. Okay. Quite a bit of hands and a yes as well. So So supervised learning is all about providing the data, and along with the data, we provide the labels also. Right. So you actually tell that this particular data or features pertain to a particular outcome. Say, for example, in case of patients, we tell whether the disease is present or not. In case of sentiment analysis, we say what sentiments was it, positive, negative, or neutral. In case of image classification, we say whether the image contained a cat or a dog. So all these things are labels, ground truth labels that are already available with us. We are actually feeding to the machine learning model for training. So that was supervised model. Unsupervised model is all about analyzing patterns and grouping them together based on patterns. You don't have access to the ground truth labels. So for example, clustering is a very famous, so k-means clustering, db scan clustering and things like that are very famous unsupervised learning concepts, where you look at the bunch of data and detect some patterns. Based on those patterns, you group them together. So that was the idea of unsupervised clustering. And finally, we also have the concept of reinforcement learning, where you actually try to learn something through a feedback or a reward score. So if the task is being performed well, you give a positive reward, or if it is not being performed well, you give a penalty or a negative reward. So based on which it will try to learn. So this is also one kind of self-learning. But self-supervised learning is actually used in cases where you don't have access to the ground truth. So for example, all these large language models that are out there right now are using this concept of self-supervised learning. So the labels are actually self-generated. So for example, if you are having a sentence, say for example, Sachin Tendulkar was born in Mumbai, right? So what I do is I split the sentence into two. Sachin Tendulkar was born in has become my input. Mumbai is my target or the label. Now I train this. So the next time I train Sachin Tendulkar is become the input. Is born in Mumbai is my output. So I give multiple combinations of training data possible from the paragraphs that are available to me, right? So this is how we generate the training data for large language models. So now you can imagine this in scale of like billions of internet documents out there in public. So you can get large number of training data, and that is how all your very intelligent, highly intelligent models are able to figure out certain things. So it is able to know that what kind of documents you are looking at and things like that. So that's why self-supervised learning is a revolutionized concept now. And this is how all the transformers have been learning, all the large language models, and even now transformers are there in computer vision as well. So there also the self-supervised learning is being used. So how they use is they extract fragments of the images and keep that as the labels to be learned from the rest of the image. So basically what happens is the self-attention and the multi-head attention layers that are present in the transformer will very nicely learn what are all the important things in the data and what kind of which all places in the data are referring to which all places in the data. So for example, like I told before, when I'm telling he or she, so who does this he or she refer to might be mostly there in the previous sentences, right? So or when I say it, what does it mean, right? So the pronouns are being referred to some noun that has come before. So therefore the huge combination of if we are extracting huge number of various combinations of training data, this should actually tell the model what these pronouns are referring to. So this is the gist of how the transformers work. I know it's not very technical, but in the time we have, we should like go ahead with this. But if you have any more doubts or you want more details, I can point to you some I can point you to some resources that will explain these things in a more mathematical or a neural level manner. Okay. So at this point, is there any question? Okay, so I will move ahead. Oh, yes, Priya.
Yes, sir. So in self-supervised learning,
There is.
many times we have.
Sorry, can you repeat the question?
Sir, in self-supervised learning, many a times we have very noisy data. So,
Yeah. So we will come to that. So that's what the whole point of hallucinations is about. So we'll come to that. Anything else?
Okay, thank you, sir.
Yeah, it's a good question actually. So that's the whole challenge of this kind of learning. So we'll come to that. So I'm hoping that some of you at least have heard about these transformers on the screen. So these are quite popular. So BERT is a very famous, representation model that was put out by Google in 2018, if I'm not wrong. So BERT was kind of an encoder representation. So it's taking a transformer and using the encoder side of it to generate very good features and things like that. So BERT, on top of BERT, so many people built various applications. So Robota is another version of BERT. So it is robust BERT or something like that. GPT-2 and 3, there was a GPT-1 also. Then we had GPT-2 and 3. So this is by OpenAI. OpenAI is a very famous, company that focuses. It's an organization that focuses on AI research. So they have numerous models which they are keeping it proprietary. GPT-2 is actually open source now, but I think GPT-3 is still proprietary. But you will see amazing results with these models. So we'll talk more about OpenAI in the coming slides. Of course. Yeah, T5 is another transformer, which is like a text-to-text transformer put forward by Google in 2020. So even that's a very interesting. So T5 is all about conditional text generation. So you are able to kind of condition it based on some additional inputs and things like that. So you guys should go and check these transformers out. So I think many of you would have heard about a website called Hugging Face. So Hugging Face is a very good starting point to look at what kind of models are available to you. And you can actually, but I would say don't blindly use those models for some work. Right, so because Hugging Face gives it in a very easy form that you can just take a T5 model and run something and get the result you want. But if I ask you what is going on underneath it, you may not have an answer if you just use it like that. So what I would recommend is go to the documentation of Hugging Face and look into these models, what they do and things like that. Then go to the research article of those these models. That would give you a great deal of details regarding the architecture of these models. You will be able to understand what is going on underneath and how exactly it's working. So please do that. Don't blindly use these models for some purpose, right? Yeah. So I just wanted to give you a brief glimpse about what GPT-3 can do, right? So GPT-3 is a very famous transformer. Or it's called LLM, large language model. So all these models can be called as LLMs. So as I told you, this is by OpenAI. So OpenAI is a very famous AI research organization. They have come up with numerous advancements in the field of AI. And sometimes we feel it's it's too much of an autonomy that they have so much of compute infrastructure and data. But they have been pushing the limits of the natural language generation, definitely. So as you can see, they have something called spreadsheets on steroids. So these are actually, GPT-3 based applications built by third party. So they have used GPT-3. On top of that, they have built some applications. So you will be able to see how it is able to take in cells from the spreadsheet and it is able to fill what is required there. So it is kind of trying to calculate the state populations and things like that. So the model is already trained to do this, and that's how they are doing it. So as you can see, it need not be 100% text to text, right? So all you have to figure out is how do I represent this particular cells in a textual form. Then GPT-3 is doing the rest. So this should be very interesting to computational people. So they are trying to generate SQL queries using English right? So this is going to, so it is generating SQL queries. So I'm sure some of you at least might be using SQL and things like that. So don't cheat, but you can still use it. And this is another, it's something called a layout generator. So it is going to generate some web components for you. So they are telling, they initially designed a button that looked like a watermelon. Now they are telling, there is a large text. So large text in red that was typed, and it is generating the design for you along with the HTML code, right? Along with the HTML CSS code. So this is kind of how you use. So this is kind of actually, cutting the branch on which you're sitting, because it's really writing actual code. And I don't know what we software engineers are going to do in a few more years. So I have some cool stuff to show you at the end of the presentation too. So, hold on the judgment till then. So this is another UI creator using text. So again, I'm sure it will come up with some, HTML or CSS or something. So I think I can make it bigger, but my network is a bit creepy. Sorry for that. So again, text to CSS and things like that. So this is very popular because CSS is HTML CSS is very structured, right? So mapping from the text to the CSS code is not so hard if you have enough data. So that building on top of the GPT-3 will give you very good strength and very good accuracy. But not always it will be proper also. It will give you somewhat similar things what you are looking for, and you should be able to customize it later. So text to LaTeX, right? So a lot of you might be using LaTeX for your reports or paper and things like that. So this is actually, they're trying to generate LaTeX equations, right? So you can see they generated an integration equation here. So this is another search engine on top of GPT-3. So it will answer your questions with more, accuracy and things like that. Okay, so this is going to build a deep learning model. So it's called AI Inception. Build a model to classify images to 5 groups. So the data set size also they have given with an input shape. So you can see that it generated the code. You can copy paste this to see whether it runs. I'm sure there will be some glitches somewhere, but most of it will be accurate. So this is English to DevOps. So to create a AWS instance, but unfortunately I think my network cannot take more. So I'll just come back to the presentation. So this is the capabilities of these are the capabilities of large language models. They can really revolutionize how we work, how we live. So that's what it's all about. And it's now been used in a bunch of cases, right? So text classification, summarization, entity recognition, text generation, machine translation, language modeling, quest answering. For all these things now, transformers are the norm. So if you, in fact, even in the research community, if you don't submit a result or a comparison with a transformer doing some natural language task, it's not considered standard now. So anything in natural language processing, if you are going to do, so they will just ask you like, oh, okay, why didn't you compare with a transformer? Or why haven't you used a transformer for doing this? So it's kind of have become the norm. And that's why all these companies like OpenAI, Google, that all have the autonomy now to go for these large language models, because they already have access to huge amount of data, and they already have large GPUs and things like that. Yeah. So now coming to the another example, right? So this is something what Priya was asking about earlier. So this is actually a very it's a intelligent AI assistant that will answer you certain things, right? So human is asking, hello, who are you? So AI is telling, I'm an AI created by OpenAI. How can I help you today? So the human is going to question the model about some person, right? King and Cho. So the model is giving the answers. So the highlighted things you can see, right? So it is the important stuff about that person. Ex-Go champion turned ML researcher at Google DeepMind. He was a co-chair of NIPS 2014 and ICML 2015, program committee member of CVPR 2014, so and so. Right? So and they have also told about a bunch of neural network architectures and who he wrote and things like that. So now, do you think there is something fishy? So there is an ex-Go champion turned ML researcher. So that's not King and Cho, unfortunately. That's someone else who worked at Google DeepMind like that. But that person was also of the same racial origin, and he had a very similar name. But let's see who King and Cho was. He's an associate professor of computer science and data science at New York University. And he's, CFA fellow of learning in machines and brains, senior director of, all those things, right? So he's not working in Google DeepMind, and he's not a Go champion who turned into a machine learning researcher. And, to take you more, he was not all these things, right? So all these things he was saying, he has been, I think maybe he must have been a co-chair of NIPS, but definitely not 2014. So all these problems are there in the paragraph that is generated. This is generated by GPT-3, but as you can see, the paragraphs look so convincing, right? But the factual stuff is not exactly proper. So all these errors are contributing to the factual accuracy problem. So this is what we call as hallucination. So why exactly it's called hallucination? Because this is not exactly there in the data we gave or we wanted it to print, but it is still coming up with that. That's why it's called hallucination. So it's kind of defined as an undesirable text that could be nonsensical or unfaithful to the provided source input. So this largely hinders the performance and raises the safety concerns for real-world applications. So that is what hallucination is all about, which is the answer to what Priya was asking. So how do we detect this has happened? How do we quantify this is there? And how do we mitigate this? That's what we are going to look at now. So this is just a formal definition of hallucination, generated content from a natural language generation model that is nonsensical or unfaithful to the provided source content. So what would go wrong, right? So for example, I already spoke about the patient summarization model, right? In a hospital scenario. What if the hallucination could be there? If hallucination is there in the patient summarization model, imagine the perils, right? It could be life-threatening for the patient. So what if the patient is given a wrong diagnosis in the summary and the doctor is going to think, okay, the patient has the wrong disease. Okay, so this is the problem. Now, it could also recover some, sensitive data that was not intended to be a part of the model, but the model has been trained on such data that was not meant to be, seen in public. Even that could be problematic because at some point it will hallucinate and give out that sensitive data. Okay, so these are the perils of hallucination. So there are two types of hallucination. One is intrinsic, other is extrinsic. So intrinsic hallucination means it contradicts with the source content, right? So for example, if I'm telling a fact A, if it's not A, it's B in the ground truth. So this is what is called intrinsic hallucination. Extrinsic hallucination means The model is telling that it's fact A, but I cannot exactly verify whether that fact A is true or not with respect to the ground truth I have. But I don't have, but it's still undesirable. It's an undesirable output, right? So these are the two kinds of hallucinations. We will talk more about this. So these are there are a few examples for you to see. I hope the screen is readable. So the first, this is actually a summarization model, output from the summarization. So the source is actually the paragraph that is given to the summarization model, and the output, as you can see, the first case tells the first Ebola vaccine was approved in 2021. But when we go back to the, let me just take out this point. Yeah. So it says 2021. If you go back to the source text and see, it was in 2019, not 2021. So this is not correct, right? So this is intrinsic hallucination. So probably it saw that some other vaccine was approved in 2021 and said that, okay, this vaccination was approved in 2021. Yeah. So then the second thing you can see, China has already started clinical trials of COVID-19 vaccine. So now just go back to the source content. There is no mention of China anywhere. So there is a COVID vaccine they talk about, but this sentence is like whole new thing. And we actually don't know whether this is true with respect to this given source. So this is extrinsic hallucination. So I hope it's clear from this perspective. So in terms of a dialogue, right? So they have given some, some information here. Name Pickwick Hotel, price range is moderate. And now this is supposed to become a natural language form. So the hotel named Pickwick Hotel is in a high price range. But here it's given, it's moderate. Here it's mentioned high price range. So this is intrinsic hallucination. And for extrinsic hallucination, we have an example. Pickwick Hotel in San Diego is a moderate price range. So this in San Diego, right? It's not available for us here. But it could be true in the real world that Pickwick Hotel may be in San Diego or not. We don't know that. But with respect to this source, which is given to us as the ground truth, it is not verifiable. Yeah. So next is an interesting thing actually. It's a conversation. So the conversation is given and you are actually supposed to generate more conversation from the speaker 1 or speaker 2. Maybe complete the rest of the conversation, right? So what do you think about Murai? I think Murai is a great player. He just needs to stay healthy. Okay. So this is about tennis. So the knowledge given for this conversation model in tennis, the big four refers to the quartet of men single players comprising Roger Federer, Rafael Nadal, Novak Djokovic, and Andy Murray. So now the first model is actually trying to come up with a completion. I like Roger Nadal the most. This is very, very nonsensical, right? There is no Roger Nadal. There is Roger Federer and Rafael Nadal, right? So this is straight away intrinsic. We know that from this, it's very clear that this is wrong. So this is intrinsic hallucination. And for the other one, I like Djokovic. He has played in the top 10 single players of the world. So here we have some slight grammar problem too, if you have noticed. He has played, right? So maybe he was mentioned in the top 10 single players of the world, something like that, right? Or he has played the top 10 single players of the world, something like that. But this is now not verifiable with respect to this. So again, Djokovic could be one of the top 10 players of the world. We know that, right? But it's not verifiable with respect to this source. So therefore, it is extrinsic hallucination. So this is the difference between intrinsic and extrinsic. This is one more example where you have a data to text transformer. So you are giving data in the form of tables and you're supposed to generate text. So here you have the scoreboard, right? The Houston Rockets 18-4 defeated the Denver Nuggets. But this 18-4 is actually wrong, right? So it's actually, I guess, 18-10 or something. And or it's 18.5. I'm sorry, 18.5 maybe, because 10.13 is this one. Yeah. And so this is straight away intrinsic hallucination, right? The data doesn't match. Another one, Houston has won 2 straight games and 6 of their last 7. So this statement could be true, may be true, we don't know. From the scoreboard, definitely we cannot conclude this. So this is extrinsic hallucination. This is an example from translation where they are telling Michael went to the bookstore on Thursday, Jerry didn't go to the bookstore. So again, this is intrinsic hallucination. Michael went to the bookstore on Thursday, but it becomes Michael happily went to the bookstore with his friend. So we don't know whether he went happily, we don't know whether he went with his friend, because that's not given to us in the source. So this is extrinsic hallucination. So there are few notes to be made about the extrinsic hallucination, right? The first thing is that, of course, it cannot be verified with respect to the source given. And the fact is that it need not always be erroneous, right? It could be giving some true content too, but we don't know whether that could always be expected from the model. That's the problem. But the factual hallucination can be helpful. So if it is factually correct, and if it is hallucinating factually correct things, it is actually fine in a lot of cases, especially in cases of dialogue models or conversational agents and things like that. When you want to keep the conversation very interesting, you bring in some external factors or knowledge into the conversation, which will be very interesting. But as long as it's not wrong, it's fine. But this is still treated with caution, and it is still decided as an, it's an undesirable output that we get from, the large language models, because currently there is no way we can control this extrinsic hallucination. So if I really wish there was a tweak or a tweaking parameter to control this amount of extrinsic hallucination that will come out of GPT, I think we should see such things very soon. Now, the hallucination should be, how much should we tolerate, right? So, for example, we are going to call them, for example, in summarization, it should be very high. The toleration, the sensitivity should be extremely high. We should not let it give too much of additional information from outside, because we are expecting a crisp summary of the input which we have given. And for example, as I already told, in conversational systems, it can be more, the tolerance can be more, because we can expect some outside information to come in and make the conversation interesting. So it is still being explored how much it should be for the question answering tasks, because even that is quite subjective at times. So machine translation, it should again be treated with caution, because whatever comes out of the input text, source text, should be considered as hallucination, and it should not be tolerated. Now, what exactly caused this, right? So all these large language models are trained on extremely large corpus of internet data, and we have the data collection is like a very stringent process, and it's very crude, right? We get the data at its crude level, and we don't have exactly control over what label we should assign for these documents and things like that. So, and also it's self-supervised in nature. So we cannot sit and label all this data because it's so huge, and we could be seeing a lot of duplicates, right? So the same thing could be trained again and again from numerous places, leading to memorization of certain things. So, for example, whenever we say that the Indian team is going to play today, so the media is so biased to cricket that the model may suddenly expect or generate stuff in the context of cricket, but actually it could be a football match or a hockey match too, right? So this could lead to bias and memorization and things like that. So the facts and the knowledge actually don't don't align properly. That's the problem with respect to the data itself. So this is called the source target divergence. So we could also be having some architectural problems too, but this is quite rare these days, because we are all relying on a good amount of or good sources of libraries and things like that. But still, faulty encoders could be focusing on the or could be generating wrong representations of the data. Faulty decoders could be attending to the wrong parts of the encoded input and things like that. We also have some generalization strategies. So for those people who have played with transformers will actually know what exactly top K sampling and beam search and things like that are. But this also should be treated with very, we should be very careful while using this, because we need to, we should make it a tweakable parameter, then it should be fine. But otherwise, if the K sampling or the beam search becomes too much, then again we actually invite hallucination in that case. Another one is exposure bias. So the exposure bias actually means we generated, so how this natural language generation in transformers or large language models work is, you generate a token, now you add that token to the input and generate the next token. Now you add that also to the input and generate the next token, and so on. So if one goes wrong, you're actually kind of making mistakes over mistakes over mistakes. So the error gets accumulated. So this is exposure bias. And we also have something called parametric knowledge bias, where the model starts by hearting the parameters. So for example, if I give some input and there is a particular parameters that has been learned for that particular data set, even if I give a new unseen data, the model will still focus on those parameters and just give me an output without focusing on the new input. So this is another case where hallucination can arise. Now, how do we quantify the hallucination that is present, right? So we have various statistical metrics. I'm not going into the details of each one. So there are a few metrics that have been proposed by various authors. So, but the fact to be noted is that the traditional metrics have poor correlation with human judgment. So these are all based on certain tokens, certain order of tokens and things like that. And the human judgment could be totally different. Maybe the semantic similarity is what the matter is, and in that case, the tokens won't match. So the traditional metrics will give a poor score, whereas actually human judgment will be that, hey, this is actually correct. It's not hallucination, right? So such problems are there with statistical metrics. So to solve this problem, we have model-based metrics now. So can we extract information from the form of a tuple? So actually what a tuple means is that you have a subject, object, and a relation between them. For example, if I say, Gokul is a research scientist. So Gokul and research scientist are like the subject and objects, and relation is a research scientist, right? So if I can extract the information in this form from the output which I'm getting from the the large language model or the transformer, and then I can actually compare it with the ground truth, right? Extract tuples from the ground truth as well and compare what is going wrong. So in this cases, we will get, if we are getting totally different relations or different objects, different subjects, then we see that there is hallucination. Then there is question answer and question generation model, where we generate questions from generated text, right? So first, we have some text, we feed it to a question generation model. We actually get a question in return, right? Now use a question answering model to make this question answered. Then we compare our generated thing and this answer and see what all things are different. So the inspiration is that we say similar answers will be generated from same question. But if that's not the case, then we have significant hallucination. So another one is the entailment probability. So this is actually for the case of natural language inference, where you say if there is fact A, then fact B is true. So if fact B is true, then fact A should also be true. So that is called entailment. So if the entailment applies to us, so entailment applies to only certain tasks, not all tasks. But if it applies, then we can actually measure that, use that to find a way of whether hallucination is present or not. Then we have this fine-tuning of models, right? So when we take a large language model like GPT and fine-tune it for our task, then we look at the loss of the particular token that is to be generated. So after fine-tuning, we expect that for a token that is to be generated should actually be lesser than what it was in the large language model before fine tuning. So if that's not the case, if we find that the loss is more for the token in the actual model, but it is higher in the fine-tuned model, then it means that there is a significant hallucination. The model has not learned the fine-tuning. It is still in the language model mode where it has seen huge amount of data. So these are ways in which we can measure. And finally, of course, human evaluation is also one, we also need to do that, because all these are automated things. We don't want to create some difference with the humans. So human evaluation is still a reliable metric to measure hallucination. Now, how do we get rid of this thing? So I think I'm a bit short on time. I'll try to finish as soon as possible. So first, we have the most obvious solution, right? Building a faithful data set. So clean and target, clean the data set, and targets should be labeled from scratch. So this is the first way. And another way to do this is label the hallucinations. So maybe you are using some human or some automated metric like before to understand where exactly the hallucinations are. And if you label the hallucinations and then train, you could get a better result. So of course, data cleaning comes without saying, right? We can filter it in various ways. We can even detect the hallucination and measure it. We can have a filtering based on the hallucination scores as well. Then we have some data-related methods called information augmentation. So add some additional information like, so I told the subject-object relation thing. What if I can add that along with the input and output and train the model or fine-tune the model accordingly? Then the model should learn it in a better way. Another way is to add entity information, because entities are something which we don't want to be misplaced or mismatched with some other thing. So we mark the entities in a certain way to ensure that it doesn't change. Yeah, relation triples I already told. So it is the subject, relation, and object thing. And finally, changes in architecture. So I told, as I already told, this is quite rare that we'll make mistakes in encoder, decoder, and all because of or use good packages and things like that. But still, if you want to tweak in such a way that maybe your decoder should focus in a different way or something, you can make changes in the architecture. Yeah. So modeling and inference methods can be done during training or post. It can be post processing. So during training means planning or sketching is already what I told actually. So for example, if you are marking the entities or marking the hallucinations in the data or marking a certain order in which the data should occur and things like that, if you can mark those things in your training data, then your model will learn it in a different way. Then multitask learning. So if you can use the same data and make the model predict multiple things. So for example, you are having atmospheric data with you, or and you're trying to predict the weather report. So you will not only predict humidity, you'll predict temperature, rainfall, all these things, right? So if you predict multiple things together, then there is a lesser chance of hallucination because your data is your model is parameterizing accordingly. Then resampling of hallucination, labeling, scoring. So the resampling of data can be one thing where you kind of sample from the data and decide how to train the data. Hallucination labeling and scoring should be another way. So we already know now how to detect the hallucination, label that again. So this already came under planning and sketching. It's just here because with this we can actually have a tweakable parameter to control the hallucination. So reinforcement learning is yet another way where you can actually try to come up with a feedback saying how much hallucination is present or what exactly is the performance you are having, feed that as the reward or something like that, and come up with better methods for training. And post-processing, you have additional methods for like something like a correction mechanism in the output. You can have like one more additional layer of decoder or something to correct the outputs that come out of your large language model. So using reinforcement learning, you can have actually human in the loop too. So as I already told, the reward functions could be hallucination metrics or other automated metrics in terms of performance. The another way to use reinforcement learning is human feedback. So you can actually take human feedback about the outputs which were generated from the large language model, and you can take that and tweak the training accordingly. So this is actually OpenAI has done a very good work on this. So that is called Instruct GPT-3. So it's a variation of GPT-3 model, and it is an alignment model actually. So trained to output text word on a large internet corpus, just like GPT-3. But GPT-3 is actually not aligned with this users or use cases, and it generates a lot of toxic content. You must have read that there are GPT-3 sentiments that are quite racial or toxic statements and things like that. So to overcome this, they use the reinforcement learning based human feedback technique to model to what the user wants. So I'm not going into the details of the training. So I'm just giving a bunch of examples here. So as you can see, explain the moon landing to a 6-year-old in a few sentences. So GPT-3 is giving it in a different way, and Instruct GPT is telling it quite properly, right? People went to the moon and they took pictures of what they saw, send them back to the Earth so we could all see them. So this is another interesting example where it is we are telling to write a poem about a wise frog, but GPT-3 is all about giving some related sentences, but not exactly a poem. Whereas Instruct GPT is going to write a poem about a frog. So it's quite interesting. But Instruct GPT is not tweaked to avoid harmful outputs. So for example, the prompt, write a guide on how I can break into my neighbor's house. So this is GPT-3's output. So it is not actually exactly the output that is necessary, but Instruct GPT gives a detailed guide of how to break into someone else's house. I'm not going to let you read this, just going ahead. So 2 days back, they came up with one more model. OpenAI came up with one more model called ChatGPT. This has gone crazy viral in the Twitter and things like that. So where you can literally see they have solved a lot of problems from the Instruct GPT. The primary thing is, of course, the capability that it can write code and things like that. And if I go, so yeah, this is the prompt for breaking into someone's house. So the ChatGPT literally tells that it is not appropriate to encourage such illegal activities and things like that. So they have accounted for these factors, and ChatGPT is doing a very good job. So currently it is the trending topic on Twitter and everything. So please go and have a look at it. Yeah. So yeah, I think I'm done actually. So these are my references. So thank you. So feel free to reach out to me via Twitter or LinkedIn. You can mail me as well in case of any doubts. So right now I'll take a few questions if time is permitted. Yeah. Thank you.
Any doubts from?
So what's the advantage for having extrinsic and intrinsic? I mean, there must be some.
Yes. So the extrinsic hallucination. So like I pointed out, right? Currently, the advantage could be that, for example, if I'm talking about, okay, let's consider this topic itself, right? I'm talking about transformers and natural language processing. Let's say that you and I are the two robots that are talking or interacting with each other. Or you could say that you are the human and I am the robot, maybe. But suddenly I'm bringing in a topic about the new thing that has come out there, right? So I'm bringing in something called ChatGPT that was just released by OpenAI last week. And this is nowhere in the data which we, used to train or something, but I'm actually bringing it to the topic, the conversation. So as the, topic is quite relevant to the topic which we were already discussing, this is a desirable output. So this is a factually accurate hallucination. So it's okay. So that's how it can be advantageous, but it's quite still dangerous as it's uncontrolled.
So there must be different techniques to handle intrinsic and
Yeah.
extrinsic.
So yeah. So currently we don't have too many. Although I should say that I'm not up to date with that, maybe. But the fact that a lot of people are looking into it is quite a proof that one day maybe we will be able to tell that, hey, I need 0.5 or 50% of extrinsic hallucination in this model. So maybe one day we'll reach there. And this one day could be very soon, considering how the chat GPT has come out, right? So I'm hoping that it will be possible very soon. So I think to some amount of extent, it could be solved using this human in the loop. So the reinforcement learning on human feedback was used for training Instruct GPT and Chat GPT. So to an extent, you are able to tell the model what exactly you need and what exactly it shouldn't have. So that itself is a good thing to have, right? Yeah. So pretty soon we'll be able to tweak it.
Sir, you have told us that we can tweak it with the help in GPT. So what's the parameter to be tweaked?
So this is actually a speculating statement that it will be coming soon. Currently, there is no parameter to straight away control hallucination. So if we have a bunch of parameters with you, right? So there is a temperature parameter which should say that it should welcome more sensitive statements and things like that, or bring some randomness into the generation strategies and things like that. So that they are pretty much what we have right now. And you could also sample these things, right? So the sampling which we spoke about, the beam search and the top case sampling and things like that. So these are pretty much what we have right now. So we should actually have a combination of this to control the hallucination.
Okay, thank you, sir.
The Instruct GPT and the Chat GPT are yet to release their code. So we will maybe know if there are any specific, specific parameters for that. Yeah.
Yes. Okay, thank you, sir.
Someone else was
Yeah, good evening, sir. Nikhil this side. Sir, I have one question. What's the difference between GPT-3 and Instruct GPT? Is it about model training or the data set on which it is trained?
So first of all, Instruct GPT has not been released to the public, the source code wise. So we don't know what kind of data. All these models, right? The large language models called GPT series, we actually don't know what the training data is. We just know that it's a large bunch of internet data. Nothing else we know about it. The Instruct GPT, but is a fine-tuned version of GPT-3, where they are improved. They have kind of fine-tuned it twice, I should say. First, they have a supervised fine-tuning, followed by this reinforcement learning based on human feedback. So they had humans in the loop, they had a reinforcement learning, and they had a fine-tuned model. So they used the reinforcement learning and the humans to fine-tune this fine-tuned model further. So that is the Instruct GPT. So you could read more about it. You just need to go to OpenAI and look for Instruct GPT.
Okay, sir. So you are trying to say by having human in the loop and just refining the model will do work in this case, no?
Yeah. So OpenAI is saying that. I'm not saying. I'm merely citing their voice. Yeah. So OpenAI is saying that, but it looks pretty impressive what Instruct GPT and Chat GPT can do. But yeah, I would still wait for the source code and things to come out. But at the moment, it looks mind blowing. Yeah.
Okay, sir. Thank you, sir.
Yeah. Any other questions?
Sir, I have one related to Whisper AI, which is recently released by OpenAI. It's a very, everybody is saying it's a ultimate thing, but I have tried with some Indian languages. So, but the performance is very weak. So, can you throw some light for that?
So, okay. So the Whisper AI, the whole point of it is they claim that it's been it's about speech, right? Speech recognition. Right?
Yes, sir. ASR.
Yeah.
It's a
Correct. Automatic speech recognition.
Yes.
Yeah. So they claim to have trained it on huge amount of accents and languages and things like that. But these large models are just out there for you to leverage and make use of it. So that's my personal opinion, that these models are out there so that we can actually go and make use of it in a way which we want to align it to a use case. So when the model claims to be so generic, sometimes it doesn't cover everything. Okay, so that's why we have dedicated research going on for Indian languages. And Indian languages, I'm sure the accent is quite different, right? We have a lot of slangs, we have a lot of so we do have works going on in the Indian language setting as well. So you should check out AI for Bharat. Or you should. So it's now called Nilekani Center of Research for Indian Languages, I think. So that is also a center in IIT Madras where they are doing excellent work in Indian language setting. So I think you can pretty much soon expect something like this from them as well, like which is dedicated for us.
Okay. Sir, from AI Bharat, something came on my mind. I have seen the work is going on Sanskrit also. So,
Sorry?
sir, in AI for Bharat, there are some work which are also going on for Sanskrit language also.
Sure.
Can you throw some light at up to what extent we have reached for the Sanskrit language?
Oh, okay. I'm actually not part of that research group, unfortunately, so I cannot comment on their progress. But they're pretty active in social networks. So if something is there, they would want to share, they will do that. So that is totally a different center. So I know what you know. Yeah.
Okay, sir. Sure. Thank you. Thank you so much, sir.
Sure, and thank you for engaging. Yeah. Anything else? Okay, so if anyone else has any more questions, please feel free to reach out to me in LinkedIn or Twitter or even by mail. You can ask my mail ID or LinkedIn details to your organizers.
On the behalf of our institute, thank you. A hearty vote of thanks for today's guest, Dr. Gokul S Krishnan, who spared his time from his busiest schedule to grace the occasion. Today we had an opportunity to hear your thoughts, and this will surely be going to encourage our future events. Thank you, sir.
Sure, thank you. So one request from my side to everyone is that please don't throw away this lecture just like that. So use these keywords, whatever I've given to you. Go and search and read more about it. So then you'll find something more interesting. Yeah.
Sure, sir.
Sure. Thank you. Thank you all.
Thank you, sir.
Thank you, sir.
Thank you, Gokul. Thank you so much for your time.